Hello, Algebra 2. Tonight's topic is 7.2, Unit 7, Day 2. And our essential topic tonight is how can I use my knowledge of fractions to simplify, multiply, and divide rational expressions. The first thing we need to remember is what is a rational number? And we're going to use the root word of that to help us remember. A ratio is a good key point to remember to help us know about a rational number. A rational number is a number that can be expressed exactly by a ratio of two integers. So again, a rational number is a number that can be expressed exactly by the ratio of two integers. So if you think about a typical classroom, we can use a ratio to talk about the students, the desks, the number of markers in the room, and but let's go ahead and think about this number of students in the room. We can say 2 out of 3 students in the room have an iPhone, or maybe 2 out of 3 students are wearing jeans or a winter coat since we've had all this snow. But what that is, 2 out of 3 is a ratio. So if we say 2 out of 3 people, we can also write that as 2 out of 3, another way to write a ratio, or we can write 2/3. And so don't forget what fractions mean. They are a ratio of numbers. So all of these mean the same thing. 2 out of 3 people is the same thing as 2/3 of the people in the room. A rational expression then is a quotient or a ratio of two polynomials. A quotient, because we can say this is a quotient, 2 divided by 3. So a rational expression would be a quotient or a ratio of two polynomials. So instead of integers, we're going to have polynomials. And one of our polynomials could be an integer. Let's fix that. Let's look at some examples. One example, a rational number for 6 over 3. Remember, 6 over 3 means 6 divided by 3, which obviously means also 2. So the second example is a good example of a rational expression where we're going to be working with this unit. And our polynomial on top is x squared, and the one in the denominator is 5x minus 1. And that means x squared divided by 5x minus 1. And we want to use our knowledge of fractions to help us throughout this unit. And if we first think about how we would simplify a fraction such as 20 over 64, we would take a look and think about what common factors do both 20 and 64 have in them. And the first thing that comes to mind is 4. 4 goes into both of those. And just to show you what we're doing, we obviously could divide both by 4. But so you can see how this is going to work with our more complicated problems. Just going to go ahead and write out 4 times 5 is 20, and then 4 times 16 would be 64. So this is an equivalent statement. Now we can see they both have a common factor of 4, so we can cancel that 4, and we can simplify 20 over 64 as 5/16. We can do the same thing with our example number 2 here. And we can also think about our laws of exponents. Go ahead and try to simplify number 2, break down the factors and see what you can cancel, and then bring it back. So 4 is 2 times 2, and x squared would be x times x. 6 would be 3 times 2, and xy means x times y. So to simplify this rational expression, I'm looking for common factors in the numerator and the denominator. And they both have a factor of 2, so I can cancel the 2. And they both have a factor of x. What's left is our simplified rational expression. So 2x over 3y. Let's take a look at the rules that are listed on your paper. A rational expression is simplified when both the numerator and the denominator have no common factors other than 1. So that's when we know we're done. So if you look at our example that we just finished, this was not simplified. They had common factor of 2 and a common factor of x. So we had to simplify that. Now the only common factors that the numerator and the denominator have is 1. The second thing to remember is that you can only divide out common factors. So bold this, underline, whatever you need to do. You can't divide out terms. So this is the thing that most students have trouble with. So we're going to spend some time on this, the rest of the notes here. An example of factors being multiplied would be 4 times x squared plus 1 all over 8. So here our factors are being multiplied. So we can simplify 4 over 8, and that would become 1/2. So that would simplify to x squared plus 1 over 2. An example where factors are terms, they're not factors, they're terms that are added, would be 4x squared plus 1 all over 8. And in this example, we cannot simplify this 4 and the 8. The 4 is not being multiplied by both items. Here it is, so we can simplify. Here it's not, so you cannot simplify. Okay, let's take a look at some more. Go ahead and turn over on the back and look at our ones on the back here. So if we think about what you can cancel, we want to be only canceling when there's factors. Let's first look at number 3 and number 5 and look how they're different. So number 3 here, see how x minus 2 is multiplied by x plus 3? So here we can cancel this common factor of x minus 2 and simplify that to x plus 3. In example 5, our factors are terms. They're not factors. They're terms. They're being added here. We have 4x minus 1 plus 3x plus 2. So we can't simplify here. All we can do is combine like terms. This cannot cancel because it's not, see how this is multiplying and this is add. So here we just combine like terms, so 4x plus 3x would be 7x, and minus 1 plus 2 would be plus 1, and all over 4x minus 1. We would look again to see if there's any common factors after we've combined like terms, but there's not. Alright, I want you to go ahead and pause the video and work through 1, 2, 4, 6, 7, and 8 and see what you think you can cancel and when you can't. Okay, so number 1, you can cancel. They're multiplying there, so you can cancel a factor of 2 and it simplifies to 6. For number 2, you can cancel and the x and it simplifies to 4. For number 4 here, you cannot cancel. This is a factor of x plus 1 times 5, so it cannot cancel with that x. So it can't cancel here. Number 6, you can. You have x plus 2 all divided by x plus 2. So that would simplify to 1. Number 7 is another example of where you can cancel. We have 3x minus 1 over 3x minus 1 squared. And remember that means 3x minus 1 times 3x minus 1. So you can cancel that factor and it would simplify to 1 over 3x minus 1. And our last example, number 8, you cannot cancel here. They're being added. You combine like terms. 2x plus 5 over x. Again, we cannot cancel these x. They're terms here. They are not factors, so they can't be canceled. Okay, let's try some more problems. So first, with our problems with simplifying and multiplying, when they aren't factors, our step 1 will be that our factor and look for common factors in the numerator and the denominator, and then cancel them. And then step 2 will be simplify. So in letter A, problem A and problem B, our first step is to factor and then look for common factors. So if we look at step 1, first let's look at step 1 and when it comes to number A. So for A, we just broke down all the factors. So 9, I know, has a factor in the denominator as well. 27 is 9 times 3. We could break it down farther, but we don't have to. A squared is A times A, and B cubed would be B times B times B. And then I did the same with the denominator and look for the common factors and cancel them. Once we've done that, what's left in the top is just 1. And in the bottom is 3a squared bc. So our final answer for part A is 1 over 3a squared bc. For number B, we were looking for a greatest common factor, and we found 5y as the greatest common factor in the numerator and in the denominator. And then we were able to cancel those common factors, and our answer would be 2y plus 3 over 7y minus 1. For multiplying, we have the same 2 steps. We're going to factor and then look to see common factors. So go ahead and think about how you would factor A and B and write out those factors, and also try to see what you can cancel and then bring it back. So for part A, we had a greatest common factor of n in both of these that we can cancel. Also, we have a factor of n minus 6 in this rational expression plus this one. These are all being multiplied, so we can cancel here. So our final answer would be 1 over n to the 7th. For part B, you should factor. This is a difference of squares, and this is a trinomial. And then look for common factors. X plus 1 would cancel, and our x minus 5. And it would simplify to x minus 1 over x minus 5. Okay, so there's going to be a couple steps here for dividing. Go ahead and pause the video and write these down. Okay, so first step is to multiply by the reciprocal. Then we factor and look for a common factor. There were several things we could factor here, and here we could even factor out a -1.